Hey, hi and welcome back. So in previous video, we did the power budget calculation and we reached to two different conclusions. The first one was our power supply should provide 5 volt on the output side and it should be capable to deliver 422 milliamps of current. Okay, so that was basically the first conclusion. Then the second conclusion was as we are going to power our system using an external 12 volt adapter or external 12 volt power supply. So that external power supply or that external adapter should be capable of providing 451 milliamps of current. Okay, so that was basically the second conclusion. So considering these 2 points, we are actually going to use one power supply IC in our hardware. And in this video, I'm going to walk you through the data sheet of that IC. Okay, so now let's start with this video, which is about introduction to power supply IC. So now let me tell you what you are going to learn in this video. So the first point is specifications of IC. So we will see the different specifications of the IC that we are going to use. Then the next point is pin configuration of IC. So we will see the different pins which are actually present in that particular IC and what's basically the functionality of those pins. Okay, so we will discuss that. Later, the next point is electrical characteristics. So we will see how much output current it provides, what voltage it's going to generate on the output side, and what input voltage it supports on the input side. So all those things we are actually going to see in this electrical characteristics section. Then the next point is structure of datasheet. So this is basically very important point. The main purpose of this particular video is to show you the structure of datasheet. So no matter what kind of IC, power supply IC you will use, that particular IC is actually going to have the same structure. So showing you the structure of datasheet is actually one of the important purpose of this particular video. Okay, so this is how basically we are going to cover this video and I hope that you will enjoy this video. Now let's start with this video. So this is basically the datasheet of IC that we are going to use in our power supply unit and the name of that IC is 7805. And this is the datasheet for this L78 series. So this is basically the common datasheet for this particular series L78 and there will be some more number in front of this 78 which actually represents the output voltage of that particular IC. For example, let's say that if the number is L7805, then it means that that particular IC is going to generate the 5 volt on the output side. And if it is L7806, then that IC will generate 6 volt on the output side. And this particular data sheet is for this manufacturer, which is ST Microelectronics. Okay, so ST Microelectronics is basically one of the oldest manufacturer of this IC. There are some other manufacturers also which manufactures this IC, but ST Microelectronics is actually the oldest one. After that, you can see here it's written positive voltage regulator IC. So positive because it's going to generate plus 5 volt on the output side, and the IC that we are using, it's actually a voltage regulator IC. It's going to regulate the voltage on the output side. That's why it is voltage regulator IC. Okay, and in our case, that regulated voltage, it's going to be 5 volt. After that, now let's see some of the features that I have highlighted. Actually, there are a lot of things in this data sheet and not all the things are actually important. So I have highlighted some of the things and we are just going to discuss those things in this datasheet. After that, now let's see the features of this IC. So the first feature is output current up to 1.5 amperes. So as per our power budget calculation, the power supply circuit that we are going to design, that power supply circuit should be capable to provide 422 milliamperes on the output side. And the IC that we have selected, it's actually providing 1.5 amperes on the output side, which is actually greater than the required current rating. That's the reason this IC is actually suitable for our application. And after that, output voltages of 5, 6, 8, 8.5. So likewise, there are different voltages which this particular series of ICs are actually capable to generate. So as I told you, if the name of the IC is L7805, then it's going to generate 5 volt on the output side. If it is L7809, then it will generate 9 volt on the output side. And if it is L7824, then it's going to generate 24 volt on the output side. Okay, so that's basically the reason why we are using this particular IC. This IC is actually capable of generating 5 volt on the output side. Along with that, it's actually it can provide current up to 1.5 amperes, which is actually much greater than our requirement of 422 milliamperes. Okay, and after that you can see here. So these are the different packages in which this particular IC is available, but we are not using any of the package which is mentioned in this datasheet. Instead of that, we are actually using a TO252 package. Okay, but although the package that we are using TO-252, it's not available in this datasheet, but still the specifications for that particular package TO-252, it's actually going to be the same. Okay, so we can refer this particular datasheet. Now let's go ahead and let's see some more information which is given in this datasheet. So this is basically the block diagram of 7805 IC, and these are the different blocks which are actually present inside the 7805 IC. Okay, and this is the input pin. So here we are going to provide the supply, and then this is the output pin where we are going to get the 5 volt output, and then this is the ground pin of this IC. And out of all these blocks, this block is actually very important, series pass element block, because the load that we will connect on the output side of this IC, the entire current which that particular load is going to drain, that entire current is actually going to pass through this particular block, which is series pass element. So generally this series pass element is transistor in case of linear regulators. Okay, so that's basically the block diagram, simple block diagram of 7805 IC. Now let's go ahead. After that, this is basically the most important block, which is pin configuration block, and they have given the pin configuration for all the packages which this particular manufacturer produces. So you can see the first pin is input pin, then ground pin, and then output pin. Okay, and then this tab, this is actually called as tab. It's basically the ground terminal. So if you put your multimeter in continuity mode, and if you check the continuity between this point and this point, then you will find that these two terminals are actually connected together, because this terminal and this terminal is actually the same. And this tab is available in this particular package because if you try to drain more current, for example, let's say 1 or 1.5 amperes of current through this particular IC, then this IC is actually going to heat up, and you can actually connect a heat sink on the back side of this IC. And that's the reason they have actually given a tab like this. Okay, so that we can distribute that heat and we can reduce the temperature of this IC. So likewise, the tab is also given for this TO-220FP package, and in case of this particular package, if you see, the pin configuration is same. So for all the packages, the pin configurations are going to be the same. So we are actually going to use the package similar to this one. So you can see input pin, output pin, then this is tab, which is actually the ground. And even in this case, the input pin, output pin, and then this is basically the tab. Okay, and these are basically two SMD packages, and these two packages are actually through-hole packages. And in case of these SMD packages, we generally connect this particular point, this tab and this tab, to the bigger ground plane in order to distribute that heat on the PCB. So this tab is actually for that purpose, for heat distribution on the PCB. Now let's go ahead, and the schematic diagram is actually not that important, so let's go ahead. So this is basically the maximum rating section, and this table is actually very important. In every datasheet, no matter what IC's datasheet you are using or you are referring, you will find this particular section which is called as absolute maximum rating section. So whatever rating that you will find in this particular section, you should never exceed that particular rating. If you exceed that particular rating, it means that you are going to damage that particular IC. So for input pin of this IC, you can see DC input voltage. The maximum DC input voltage that we can provide for the IC is 35 volt. And we are referring this value, it's because the output voltage in our case, it's going to be 5 volt. So that actually lies in this range. That's the reason we have to refer this particular value. Okay, so that's basically the maximum voltage we can provide to the input pin of the 7805 IC. Okay, and if you try to provide voltage more than this one, then that particular IC or 7805 IC will get damaged. So you should never exceed the values which are given in this absolute maximum rating section. So now let's go ahead, and this is basically the application circuit of 7805. So you can see the circuit is very simple. The input pin, output pin, and then ground. And on the input side, we have to connect one capacitor. Again, on the output side, we have to connect one more capacitor, and they have also given the values of these capacitor. On the input side, we have to connect 0.33 microfarad, and on the output side, we have to connect 0.1 microfarad. But in our power supply circuit design, we have actually used some different capacitor. We have used 100 microfarad and 0.1 microfarad capacitor. And why I have used that particular capacitor, I will explain that when we will discuss the power supply circuitry in detail. Okay. So at this moment, just remember that this is basically the value 0.33 microfarad on the input side and 0.1 microfarad on the output side. So the circuit for this particular IC is very simple. You have to provide certain voltage on the input side, and then you will get the 5 volt or the desired voltage based on the IC number on the output side. Alright, so now let's go ahead. After that, you can see here they have given some some more application circuit. So these circuits are actually not that important for us, so let's not refer them. After that, this is basically one of the most important section, which is electrical characteristics section. So no matter what datasheet you are referring, whether it's a power supply IC's datasheet, linear regulator IC's datasheet, or you are referring to a controller's datasheet, okay, you will find this particular electrical characteristics section. And the information which will be given in this section is actually very important. Whenever we design the circuit, at that time we actually consider the information which is actually given in this section. So here they have given some electrical characteristics for the IC that we are using, which is 7805. Okay. And these all characteristics that you see in this particular table, they are actually provided for the input voltage of 10 volt and when the current output current is 1 ampere. So 7805, so I will explain you that with this example, with the example of this IC. So they have provided 10 volt on the input side and they have connected a load on the output side which is actually draining 1 ampere. And in this situation, they have actually provided this electrical characteristic. So now let's refer to this electrical characteristics for 7805 IC. So in this table, I have just highlighted two characteristics. The first one is output voltage and then the second one is dropout voltage. Okay. So you can see the output voltage of the IC 7805 is 5 volt. The minimum is 4.9 volt and the maximum is 5.1 volt. But generally, this is basically the value that we consider, which is actually the typical value. Okay. So we always consider this value, or most of the time we consider this value. So the output voltage is 5 volt and later the next parameter is dropout voltage. So this dropout voltage is actually very important. And for this datasheet, if you see, the dropout voltage is actually 2 volt. It means that when we discussed the block diagram, at that time I told you that there is a pass element. So on that pass element, the 2 volt is actually going to drop. So what exactly that means, if we want to generate the 5 volt on the output side of this 7805 IC, then the minimum voltage that we have to provide on the input side of the 7805 IC, it's going to be 7 volt. Because this 2 volt is actually going to drop across that pass element. Okay. So if we provide 7 volt on the input side, then 2 volt will drop across the pass element and then we are going to get the 5 volt on the output side. Okay. And now let's go ahead and let's see what they have given. So likewise, they have given the electrical characteristics for the different ICs. So this is for 7806. So likewise, they have given for other ICs also 7808. So likewise, they have given the electrical characteristics for the different part number. So I will just ignore all of them because we have already discussed the electrical characteristics for 7805 IC. Now here they have given the application information. So the IC that we are using, it's actually not that so complicated. So we don't need to refer this application information section. But generally, whenever we use a power supply IC, if it is very complicated, for example, when we deal with the SMPS IC, switch mode power supply ICs, at that time we actually, refer the application information section. But the structure or the circuitry of this particular IC is very simple. So even if we don't refer this application information section, it's completely fine. Okay. But you can read the information which is given in this section. Now let's go ahead. So here again, they have given some sample application circuit. So these are actually not important for us. Now let's see what else they have given in this datasheet. So this is basically the typical performance graphs. So again, these graphs are actually not that important for us at this moment. So let's ignore them. And here they have given the package related information. So in starting of this datasheet, we discussed that this particular IC is actually available in different packages like TO-220. So the package related information like dimension, all those stuffs are actually given in this section. Okay, so here you will see all the information related to the package, the dimension, like distance between the two pins. So all the information related to the package you will get here. And again, this information is for TO-220 package. Now let's go ahead. So again, this information is actually for TO-220 FP package, and this information is actually, it's helpful when we design the footprint for a specific component. For example, if you want to design the footprint for DPAK package, then in that case you have to come to this section and you have to refer to these values, and later you have to input these values in the EagleCAD software, and later you will get that particular footprint. And we have already discussed this entire process, right? So in the same way, if you have to design this particular footprint for this particular package, then you have to come to this section and you have to refer to all this information. Okay, and this is basically the footprint related information. So you have to enter the package related information. You don't have to enter the footprint related information. Automatically the Eagle software is actually going to generate the footprint of this dimension, and you will notice that the dimension of the package will be different and the dimension of this footprint will be different. So the footprint is actually going to be little bit bigger compared to the package of the IC, and it's obvious then only we will be able to solder that particular IC properly on the footprint, right? So now let's go ahead. In the same way, they have given the package related information for D square PAK package, and also they have given the footprint related information for the same package. Okay, so you have to refer all this information, and this package related information you will see in all the data sheet of all the ICs. Okay, so that's what so that's all about the data sheet. I hope that you got the structure of the data sheet. So they have the diagram, pin configuration, then the maximum rating that we discussed, absolute maximum rating, electrical characteristics, then application information, then typical performance graphs, then package related information and ordering information. Okay, so these are basically the different part numbers. For example, if you want to order the regulator IC with 8 volt output, then you can use this particular part number. So likewise, they have given the part number for different output voltages. Okay, alright, so that's what I wanted to tell in this video. I hope that every single thing that we discussed in this data sheet related to this 7805 IC is now clear to you. And also we discussed the structure of the data sheet. So next time, I hope that whenever you will refer the data sheet of any of the power supply IC, you will refer it confidently. Okay, alright, so now I will see you in the next video, which is about understanding circuit of power supply unit. Okay, so in that video we will discuss the power supply circuitry in detail. Okay, so see you in the next video now.